Hi, Assalamualaikum. My name is Muhammad Azri bin Alias. My metric number CE200059. So today I want to present my PSM1 presentation. The title, which is the development analysis of 24-volt battery charger controller with PID for e-bike application. My supervisor is Dr. Mat Zarafi bin Ahmad. So this is the contents that included in the slide. So the first one is the problem statement, the objective, and the last one is the methodology. For the problem statement, to develop and construct a 24-volt battery charger prototype for e-bike with high efficiency, portability, and dependability for use in an e-bike application. The charger must be able to deliver a constant charging current and voltage regardless of the battery state of charge or other external circumstances, and it must be capable of safely and effectively charging a 24-volt lithium-ion or lead-acid battery. Additionally, the chargers must be simple to use and able to inform the user of the charging state, including the charging time, current, and voltage. Lastly, able to avoid harming the battery or other components. The charger must also contain safety features like over voltage protection, over current protection, and thermal protection. For the objective of this project, the first one is to simulate DC converter and battery charging circuit for e-bike application. Objective number 2, to develop a 24-volt battery charging prototype circuit for laboratory testing. Objective number 3, to compare the results through simulation and laboratory tests. For the previous related work that related to this project, first one is the battery swapping stations. Battery swapping stations, or BSS, are facilities where electric vehicle (EV) batteries can be quickly and easily replaced with fully charged ones, allowing the vehicle to continue its journey without a long wait for recharging. This can be a more convenient and efficient alternative to traditional EV charging methods, which is charging the empty battery with the full charged battery. And it also can help to reduce the range anxiety often associated with electric vehicles. The second example is the wireless charging. Wireless charging is a technology that enables wireless power transfer from a power source, for example, charger, to load like mobile phone, across an air gap. The technology provides convenience and better user experience. Recently, wireless charging is rapidly evolving from theories towards the standards and adopted in commercial products such as mobile phone and other portable devices. The advantages of this wireless charging is that it makes the temperature of the device increase hotter. And then the methodology of this project, the equipment and simulation. For the PSM1, I'm creating a simulation using MATLAB software to demonstrate the working principle of the project. For example, we have two circuits for DC to DC buck converter, and then the battery charging and discharging working principle. And then for PSM2, I'm going to create a prototype of the project based from the simulation of the software. So this is the software simulation. For example, for the DC to DC buck converter, which is the power converter that converts a high voltage DC input voltage to a lower voltage DC output voltage. And then the second circuit, which is the battery charging and discharging, the process of using computer software, which is MATLAB, or hardware to model and analyze the behavior of a battery system during charging and discharging cycles. So this is the flowchart. We start and then design the DC to DC buck converter, design charger controller, and after that we run a simulation buck to buck converter using MATLAB and also the battery charging and discharging, and then we get the output wanted. And if it's not successful, we just adjust the PI controller, and if it's successful, then we proceed with the construct of the prototype. So this one is the recommendation for future work, which is for PSM2. The first one is to complete the next phase of the project by proceeding with the project prototype based on the data collected from simulation. And then if there is any chance to create a further improvement with decreasing the duration of the time charging and then increase the safety purpose. That's all for the slide, and then I'm going to proceed with the simulation of the MATLAB. So this one is the buck to buck converter, which is already run. And then as you can see, this is the V input, which is stands at as we can see from the scope, it stands at 230 volt. And then just continue this one. Alright, this one the V input. And then for voltage output, the voltage output is around 24 volt. Same with this scope. And then the current output, you get around 1.185 amp for the buck to buck converter for the current output. And then for the battery charging and discharging output, this is the circuit that I use. So I'm going to show you the working principle of discharging and charge. First of all, the SOC, the state of charge, which is the power inside the battery. I set here at 45%. So the battery is charging currently because I set the input one here. So this one the SOC, and then we can see the current output here. Okay, and this one for the voltage. The voltage is charging. You can see here. And then if I turn this to 0, and then the SOC will go down because the battery is stop charging. Okay, and then the power is decreasing and the current will increase here. This is the output of the current, and this is the voltage will decrease from 26 volt. This is the output of voltage during the discharge process. This is the current output for discharge process. This one here around 7.5 amp. Then we start to charging again. So the battery will start to charge. And this one the SOC start to increase. Okay, I think that's all for me. Thank you and Assalamualaikum.